طيب بسم الله الرحمن الرحيم. So we started to talk last time about the categorization of networks with respect to the coverage of a specific geographical area. So we talked about two types, LANs and WANs, local area networks, where the network actually covers a small geographical area, and wide area network, where the network can cover wide regional area. And we have said that the LAN is terminated by a router port. So whenever we see a router, okay, so the what's connected to the router port is actually a local area network. In other words, the LAN is terminated always by a router port. So whenever we see a router, that means that we have a multiple LANs, multiple local area networks. So if we interconnect multiple local area networks, okay, through some routers, switches, and hubs, we have what we call a WAN, and the ultimate WAN is the internet. So another categorization of networks is with respect to privacy, or with respect to whether the network supports private communication or not. So we have the concept of the intranet and the extranet, and then the internet. So the internet is again is an interconnection of LANs and WANs. We know that, but internet by default supports public communication. Public communication means that it's mainly used for communication between people with no restrictions on the privacy or any kind of security. Of course, there are some security implemented in the internet, but the internet by default is made for public communicate, which means that internet is not owned by a person. It's not owned by any private organization. It's not owned by a single organization. Okay. The other extreme of this is what we call the intranet. So whenever we say the term intra here indicates that it's within, or it's something internal. So intranets are private and secure networks that is owned by a single entity or a single organization. Okay, a perfect example of this is مثلا the intranet for Apple, or the intranet for Microsoft, or the intranet for IBM, and so on. So each of these organizations, they have their own intranet. Okay, and this intranet supports only private communication for this particular organization, which does not necessarily have to be localized in a small area, as we can imagine. Of course, Apple or Microsoft, they have branches all over the world, but these branches, they can communicate with each other under the umbrella of Microsoft, and this communication is private, which means that no one can see this type of communication that's made by Apple branches or Microsoft branches, and so on. Which means that intranet are so this categorization is totally different from LANs and WANs. It's not bounded by geographical area here. What we're talking about is with respect to whether it provides private information or private communication, and whether it's owned by a single organization. Okay, which means that the intranet actually utilizes the infrastructure which overlaps with the internet, but we have to be able to use some technologies, like if you must have heard about VPN, for example. So if you want to have communication from home and be able to communicate with all the servers at QU, then you have to use a VPN. Once you use VPN, it allows you to be part of the private network of QU. It's as if you are physically located at QU, although you're not located at QU. So this VPN allows you to, it's called a virtual private network. By the word private, we mean that this communication that you have using VPN is going to be totally private and no one will have access to it except the organization that you belong to. Okay? So the definition here has two conditions. Private communication, and it's owned. So this is the intranet. Okay, it has two conditions for private communication, and it's owned by a single organization. Okay, this is condition number 2. So if we relax this condition and say it's for private communication, but it's not owned by a single organization, then it becomes the extranet. So extra here refers to the term that indicates external communication. So for extranets, it's actually owned. Sorry, it's for private communication, and it's owned by multiple or more than one organization. Okay, so if it's owned by one organization, it's intranet. If it's owned by more than one organization, it's extranet. In other words, if for example Microsoft would like to communicate with Apple, okay, as you can imagine, this type of communication is also private because they have to share some confidential information, some important documents or code or something like this. So again, this type of communication is private, so it has to use the network, but in that case, this network is not owned by Apple only, or it's not owned by Microsoft only. It's owned by both. So there is a part of the infrastructure that Microsoft can use to share information with other organizations, again in a private fashion, not in a public way. So if we relax these two conditions, it's not for private communication, and it's not owned by single or more than one organization, then it's internet. So internet is for public, which means that anyone can communicate on the internet. Okay, anyone. It's not restricted by one or two or three organizations. Okay, any questions here? So this is another type of categorization for networks. Okay, so if I'm an organization or a person, if I'm a user and I want to connect to the internet, okay, what do I do? Okay, so that's this is about what we mean by internet access. And internet access is done through some internet service providers. For us, of course, the most common is Ooredoo or Vodafone. So these are internet service providers. Okay, so internet service providers, they provide internet service through multiple ways. Okay, of course, in the past, maybe in the 90s and early 2000, we used to have what we call DSL, or digital subscriber line. Many of you did not live these days. So in digital subscriber line, we used to actually dial a phone number to connect with Ooredoo. Once we dial the phone number, our telephones at home are dedicated to have internet access, which means that while we are connected to Ooredoo to have internet access, we cannot even use our landlines for phone calls or something like this. خلاص, the phone is totally dedicated, and we have specific phone numbers that we call. Of course, you are not familiar with this because it was way in the past, in the 90s. Okay, and the rates for DSLs. The good thing about DSL is that it uses the phone, the landlines at home, to have internet access, and that was a revolution at that time, because we used to use phones only for phone calls. But the fact that we use the phones for extra usage like internet access, it was a revolution at that time. Despite the fact that the traffic or the data rates that we used to have are not more than like 60 kilobits per second. Of course, 60 kilobits per second nowadays is too low. Okay. Another technology that Ooredoo used to use was the cable or dedicated lines. So these dedicated lines are L1 or T1 connections, and only rich people or some users with very high profile, they would use these dedicated lines to have access to the internet through the service providers. So instead of 60 kilobits per second, this would give you maybe 1 megabits per second maximum. Of course, again, nowadays that's a bit low. So nowadays, these cables, instead of using copper cables or something, now we enjoy the fiber to home, which gives you a minimum data rates of 10 megabits per second. This is the minimum. It starts from 10 megabits per second. Okay, so that uses a specific type of dedicated cables using fiber optics. Okay, so that's the second technology. So DSL or digital subscriber line is one technology. The second technology is dedicated cables, whether it's copper cables or fiber optics. The third type is cellular, and of course we use cellular, and we live the days of 2G or second generation cellular. Of course, nowadays we enjoy 5G, and 6G is even in the making. They are developing 6G now. So we nowadays we commonly have 5G, where again the data rates can get in the range of hundreds of megabit per second potentially. Okay. Another technology that uses satellites. It uses satellite for communication. This type of technology, it used to exist in the past when actually the data rates were low, like 60 kilobits per second. And the reason for this is that for satellites, all types of communication has to go all the way to the satellite and then come back, and that has huge amount of propagation delay. In any case, it supports very slow traffic. Okay, when we started to have dedicated infrastructure using cables and stuff like that, we stopped using satellite communication. But nowadays it's coming back. It's coming back with some advanced technologies in satellite that will allow us to have megabits per second traffic. And not only that, satellite communication is very good for remote areas and like villages, remote villages and stuff like that. So you can cover the entire Earth without having to have dedicated infrastructure. Anyway, so these are all technologies that we used to have in the past, and of course, the slowest one is actually the dial-up phones, as I said. Okay. So this is for connecting users, single users, to the internet, and we have all these possible ways for accessing the internet. For connecting organizations or small and medium businesses, of course, the technologies are more sophisticated. Of course, we still have satellite communication or we used to, and we still have DSLs, but more commonly we use Metropolitan Ethernet. So, for example, QU, they have internet access through Metropolitan Ethernet, where they have routers and switches that are directly connected to Ooredoo. Okay, so here we have some routers and switches that connects us directly to Ooredoo through high bandwidth links. So we have more than one dedicated line that will allow us to have very high data rates at QU. So this is QU and this is Ooredoo or Vodafone. So using this Metropolitan Ethernet technology, we can get very high rates, but this requires again that you have to have infrastructure using routers and switches. Okay, so that's this is how we get internet access. So now we need to talk about the network as a platform. So what are the features or the properties of the network that allows the network to have multiple services and allows the network to scale up very rapidly as we see nowadays. So the internet, the number of subscribers and users for the internet, as you can imagine, it increases exponentially every day. So how can we, with this rapid growth, exponential growth, how can we maintain the performance of the internet as we have nowadays? So the number of users is actually increasing rapidly, and yet the amount of traffic that we send on the internet is also increasing rapidly. So how can we do that? So there is the concept of converging network. By converging network here, I mean that in the past we used to build the entire network, for only one single usage. Okay, so we used to have, for example, public switch telephone network. So this is what we call public switch telephone network. So this is a network that's built of switches and many network devices and stuff like that, and it's used only for making phone calls, landlines, fixed landline phone calls. So this is what we call the public switch telephone network, and it's a network infrastructure that is built only for that purpose. It's just to make phone calls. And we also used to have, of course, Ethernet or Wi-Fi or whatever, which again is built using separate infrastructure, and it's again used for data communication only. Okay, so in the past we did not have the luxury of using the data communication network for phone calls. We didn't have that. Okay, and also for TV, again, for TV, we used to have, again, separate network, which again includes some satellites and broadcast stations and so on. All this infrastructure is also used only for TV broadcast, right? So that's what we used to have in the past. Okay, nowadays it's converging. It's converging in the sense that now we have the same infrastructure, okay, but we can use all these services. All these services can utilize the same infrastructure. Okay, so why do we do this? Of course, from the perspective of the telecom provider, this is much better. Why? Because using the same infrastructure, I can provide diverse set of services. Okay, which means it's cost efficient. Okay, so this is much more cost efficient. I can have multiples of users. Some users are using games, some users are using TV, some users are using data communication, some users are making phone calls. All of these types of applications and services, they use the same infrastructure. Okay, so for telecom providers, this is attractive because it's cost efficient, right? But the issue here is that this type of infrastructure needs to be extremely smart. Okay, it needs to have a very high level of intelligence just to customize this infrastructure for the diverse set of services that this infrastructure is used for. So for example, if I'm watching TV over the network, definitely I'm utilizing different amount of resources from the network compared to some guy who is browsing the internet. Okay, so the requirements from the network are different. Therefore, the network has to be very intelligent. It needs to tailor its resources based on the usage, based on the different types of services. واضح كده؟ So how can we do that? How can we have this converging network? This is what we have nowadays. So we have Uridu access to the internet using the same device or the same router from Uridu. We can use that for watching TV, right? We can use that for internet communication. We can use that for making phone calls. We can use that for gaming. We can use the same access of the internet for diverse set of services. So in order for us to do that, the network has to have very sophisticated features that will make the network very, very intelligent. So these features include, one, we need to have fault tolerance. So we will talk about these features one by one. So we have fault tolerance, of course. We have scalability. We have quality of service. And we have security, of course. Okay? So fault tolerance here is defined as the ability of the network to work under faults or under errors. Okay, so even if part of the network is down or if part of the network has any problem, we can still have communication going on, which means that the network is not a single point of failure. Once you have a problem, the entire network is down. That's very bad. The internet or the network in general needs to have fault tolerance. Even if there is some error, the network still it continues to function as if there is no problem. Okay, this is what we refer to as fault tolerance. Scalability here, scalability means that when we grow the number of users in the network, the performance perceived by each user will remain almost the same. Okay, so if, for example, if I have Uridu network and there is a router here, and there are two users connected to this router, or they are having internet access. So there is user one and there is user two. Okay, so assume that the actual traffic that this network can provide is, let's say, like 1 megabits per second. Okay, so if we do like very simple math, and we can say, okay, so I have 1 megabits per second and I have two users. So what is the bandwidth that each user takes? It's actually 0.5. Okay, so if I increase the number of users and this bandwidth remains the same, then what each user will have is one third, and one third. And if I increase to 4, it's 1/4 or 1/4 per user. If I increase to 5, it's 1/5, and so on. Which means that by increasing the number of users, the performance goes down. That's bad. That's not scalable. That's not scalable. Okay? So scalability here talks about the fact that despite the fact that the number of users is growing, okay, the performance perceived by every single user will remain almost the same. And the word almost here is very key. I try my best to keep the performance the same, but if it's lowered a little bit, it's also acceptable, at least within range. Okay, so that's what scalability means. Scalability means that if I grow the network very large, the performance perceived by every user will remain almost the same. Okay, متابعين ولا انا is it okay? Okay. All right. So quality of service. Quality of service quality of service is actually summarized by one single word. Quality of service is all about, it's actually all about a discrimination. Okay, واحد يقول لي discrimination is bad. لا, discrimination here is good. I can convince you that discrimination in that context is actually good. So I will explain that in a minute. So quality of service here talks about the fact that we discriminate the resource, or discriminate the type of service that we give to each user based on two things: based on the type of service and based on the user himself. Okay, so for example, a person who's watching video or watching YouTube real time is different from another person who's just browsing the internet. The requirements for these two users are different. Okay, if a user pays a lot and another user pays less, I should not treat them the same. Okay, so the telecom provider cannot use absolute fairness, okay, when we deal with these types of users, despite the fact that each of them paid different amount of money. So here the discrimination in a good sense. We discriminate between the users based on the type of service that they are using and based on the type of user, whether this user is actually like a high profile user who paid a lot or a normal user who paid less. This is actually the core intelligence of the internet. This is what makes the internet nowadays conversion, the quality of service. Okay. Number 4, of course, security. And again, security makes the services diverse, because again, the type of security required by different applications is different. If I'm using the internet or the network to do bank transactions, okay, I cannot have the same level of security like someone else who's just browsing the internet publicly. Okay, so we have the dark web, we have very highly secure type of networks, and we have a network that's very, very public and unsecure. So we have the two extremes, and depending on the application, again, the security requirements are different. And the network should tailor for these different requirements from the application. So again, to go through each of these features in more details, we talk first about fault tolerance. So fault tolerance here, again, it's the ability of the network to work under fault. So to explain fault tolerance, we talk about two types of networks. One, or A, is circuit switching. Circuit switched networks here uses the concept of circuits to establish communication between any two entities. In other words, in the past, we used to have the public switched telephone network for landline phone calls. Okay, so whenever a phone wants to talk to another phone, whenever two users wants to call each other, the first phone will dial. When you dial, what happens is that this call will go to the network and will establish an end-to-end circuit. That's why we call it a circuit switched network. This circuit will be dedicated for this communication throughout the entire call. It's a physical circuit. It gets established through these switches. So to understand that, I can give you like some extreme examples. So imagine if I have like some group of people here which represent the amount of the data that comes from the phone call, the voice. The voice gets converted, of course, into packets and frames, and these will go through the network. So imagine if I have group of people like this, and I want to send this group of people to QU. Imagine that this one is QU. Okay, so I can tell these people, okay, just wait. First, I have to establish a tunnel. I have to establish here a tunnel. Okay, so, and I have to build that tunnel. So first, I have to spend some time to build that tunnel, which is a physical circuit that I have to work on building, establishing. And then once I do this, I will ask these people to go through that tunnel from point 1 all the way to QU. Of course, in that case, these people, they will not have to think. They will have to go through the tunnel. They don't have to go anywhere. They arrive here in the same order where they started, of course, right? So they will arrive in the same order, okay? And actually, based on the width of the tunnel, I can estimate how much they will take. Exactly, okay? So everything is predictable in that case, once I build that tunnel for them, okay? So this is the advantage here, is that once I build that circuit, everything else is actually deterministic, and I can estimate exactly how much time they will take, and they will arrive in order, and everything is good. But what is the disadvantage here? The disadvantage here is that on one hand, I had to spend some time to build that tunnel. I had to build that circuit, and that takes huge amount of time. What else? Imagine when we talk about fault tolerance, imagine if one switch here goes down. We'll talk about fault tolerance. Okay? This means, for example, that part of the tunnel is now destroyed. Okay? So for us, if one switch is down, the whole path end to end is now not valid. I have to re-establish another circuit, possibly maybe through another switch. Okay? So I have to establish another physical circuit through other switches. And of course, this is not fault tolerant in that case. Okay? So if I have to re-establish another physical circuit, that will take huge amount of time. So first I have to drop the entire call end to end. I have to re-establish another circuit, and then I start the communication again. That's not fault tolerant. Okay, so that's a big disadvantage. How can I resolve this? Nowadays we have different type of networks, which we call it packet switched networks. Packet switched networks. The internet uses that concept now. Okay, so if one person or one sender wants to send information to the other destination, we don't have to spend time on building a physical circuit. Again, if we go back to our example, we have a group of people here, and I will ask them to go to QU, but I will not give them any information. I will tell them, just go to QU. I will not build a tunnel for you. Just go figure how to go to QU. Okay? So in that case, each of these people, they may actually take different route based on their knowledge. So they may actually ask some person here, which represents the router, how can I go to QU? Maybe the router will send them this way, maybe the router will send them this way, maybe the router will send them this way. Okay? Maybe some of these people will go through different directions. Is that good? Yes, it's good. Why? Because now I'm actually utilizing different resources from the network. I'm utilizing different paths. So why this is good? Imagine again, if we go back to our example, this router is down. If this router is down, now the communication is still going on. Except maybe this packet maybe will go down. But all the other packets, they will flow through other path, okay, and they will still continue communicating. So this type of network, it has very high level of fault tolerance, very high level of fault tolerance, and that's actually good. And that's why the internet nowadays, it uses this type of packet switch networks. Muhammad. Yes, yes, go ahead. Yes, yeah, not all, you're not fully occupied. Yani I'm sending some packets will go this way, some packets will go this way, some packets will go this way. Okay, so so that doesn't mean that they are fully occupied. By the way, يعني different users can send their traffic through different paths. What I'm saying is that this is actually better in terms of fault tolerance. This is better in terms of fault tolerance. And the advantage here is that I didn't have to spend time on building a circuit. So if I want to communicate, I can just send the packets directly without having to worry about building a circuit. Go ahead. There's no connection here. There's no connection. Connection means that I have to establish a connection end to end. Here I'm not establishing any connection. I want to send some packets or that represent a voice or a video to a specific destination. I don't have to build a connection. I can just send them right away. And the routers here, they will figure out how to route these packets, okay? And all of these paths, they will reach to the destination at some point. They will reach to the destination at some point. The question that I was more expecting is that, okay, so what if this router goes down? Because all these paths, they share this router, مثلا. Okay? So all these paths, they have to end to this router that goes to the destination. But again, I can again build the infrastructure so that it has more fault tolerance. I can have different path for different traffic that goes to different destinations. So I can build the topology of the network in a way that's more fault tolerance. Okay, that have more fault tolerance. واضح كده؟ Okay. So packet switch networks, they have high level of fault tolerance, and that's what the internet uses nowadays, and that's why my infrastructure or the topology of the network is kind of customizable. If part of it is down, I can always rely on other parts and continue the communication without having to drop the communication from totally, and rebuild the communication and so on. So the communication is always going on, and if there is any problem with the network, only small part will be affected, but the other parts of the network will still go on, and that's a good feature that we want to have. So fault tolerance makes the network very flexible. Um, Scalability. Oh, okay. So scalability here again talks about the fact that the every day we have users joining and accessing the internet. So how can we make the internet as flexible and as scalable as it is today? So in order for us to do that, we rely on the concept of hierarchical, we call it a hierarchical service provisioning. By hierarchical service provisioning, I mean that if I'm at QU, I want to have access to the internet. Okay, so first I need to figure out how to take that service from a local internet service provider. So ISP here stands for Internet Service Provider. So first I have to look for a local service provider, okay, that can give me access to the internet. And of course, here in Qatar, we have two choices. We have either Ooredoo or Vodafone. Once I select the service provider, I make some agreement with them. Like I'm talking about big organizations like QU مثلا ولا حاجة كده. Okay? I have to make some agreement with them, and I have to build the connection or the access technology whether using some dedicated lines, metropolitan Ethernet, and so on, and connect to that local service provider. The local service provider for us is Ooredoo or Vodafone. Okay, but actually these service providers, what they do is that they take internet service access from a tier 2 service providers. Okay, tier 2 service providers, that includes, like for example, let's say مثلا Vodafone actually is also can be considered a tier 2 because they have infrastructure that actually spans all over the world almost. AT&T مثلا. Okay, so they can be considered a tier 2, and these tier 2 service providers, they can actually take their service also from tier 1 service providers. Tier 1 service providers are very much low in number. So we have maybe around 15 or maximum 20 service providers that cover the entire globe. Okay, so that includes مثلا Verizon, some service providers in China. I don't know the names exactly. They are very much focused in the US and China and other parts of, but they are low in number. They are like 15 or 20 service providers in the tier 1 category. As I go from one tier to another, the service provider tends to have huge infrastructure, huge. So they definitely use huge amount of resources, servers, switches, data centers, things like that. Okay. So this hierarchical service provisioning allows me to grow the resources up and down as the number of users grow up. Okay, so if the demand from the users goes up, I have to increase the amount of resources in the network so that the performance that each user has will be almost the same. Okay, so it has to work this way. So we have to customize our resources. It goes up and down based on the demand from the users. That's how we make the internet scalable. So we make it scalable using two things. The hierarchical service provisioning. So the service of the internet or the internet service is done in a hierarchical fashion. It goes from a local service provider to tier 2 to tier 1 service provider. Okay? And number two, if the number of users grow large, the service providers, they have to proportionally increase the amount of resources so that these users can perceive almost the same performance despite the fact that their number grows large. واضح كده؟ So that's scalability. So the third feature here, which is extremely important, quality of service. And again, quality of service is all about, again, discrimination in a good sense. So if we go back to our example, so we have the Ooredoo network here, and here we have some router, and this router we have two users, user 1 and user 2. Okay, user 1 uses like video streaming, maybe through like some gaming application or YouTube or something like this, or watching a high definition TV or something like this. User 2 is using web browsing. Okay, so if I have here fixed amount of resources, if I allocate fixed amount of resources to these users, let's say like مثلا 10 megabits per second, do you think I should divide these 10 megabits per second equally in such a way that this one will take 5 and this one will take 5? Is that efficient? Of course not, right? Because of course this guy, the video has very high requirements. It's called time-sensitive communication. Video is time-sensitive in the sense that if I'm watching, like for example, a game on YouTube or something, or some TV or something like this, it's very time-sensitive because it's interactive, okay, and it's very dynamic and it changes a lot. So if I have maybe 5 megabits per second here and 5 megabits per second here, the performance that I will have is that here, this guy will not be able to watch TV. This guy, of course, will be extremely happy, but this guy will not be able to watch TV. The video will pause every now and then, and this guy will be very frustrated, okay? So I have to, as a telecom provider, I have to discriminate between these users, okay? Not because not because of anything, but because of the type of service that they are using. If I give this user maybe 8 megabits per second and this user 2 megabits per second, both of them will be happy, okay? Because the user who is browsing the internet, displaying normal pages, if that user goes through some delay, like if you click on a web page and it takes like 10 seconds to load, not a big deal. I will tolerate that. But if I'm watching a game and then you tell me, oh, okay, so you have to wait for 2 seconds for every single frame that you receive, that's not gonna be a good quality of service, right? So the network here has to have priorities. So this router has to have very important concept, which is priority, okay? Priority based service, okay? So video service takes higher priority compared to web browsing. Audio service, like for example for phone calls, should have higher priority compared to web browsing, okay? So there is time sensitive and non-time sensitive. There's also high importance when it comes to the user. So this user, if this user pays high amount of money and this user pays low amount of money, this user will get مثلا a 100 megabits per second plan, and this user will get 10 megabits per second plan. Why? Because this user paid a lot more, right? Natural. So do you think I should say after receiving all this money, I should say no, I have to be fair and allocate the bandwidth equally? It doesn't work this way. It's not normal. So I have to give this user more share of the bandwidth because he's more important, because he's paying more money. So the network has to discriminate between the users based on two things: based on the type of service and based on the type of user. I cannot deal with a single user at home, okay, in the exact same way like a client like QU. I cannot say that both of them are equal. Okay, I cannot do that. I cannot say that user who's watching high definition TV should have the same treatment like another user who is browsing the internet. Okay, so I have to have certain type of discrimination. In order for me to do that, these routers, they have to be very intelligent. They have to be very smart using the concept of priority. And of course, finally, the security. Again, security requirements for these types of applications is different. So we have communication security and we have information security. So communication security talks about securing the information or the data while it's being transmitted, okay? Which means that I have to hide the communication. I have to use some confidentiality while the data is being transferred. And of course, you have all heard about encryption and so on. In some cases, I have to have VPN to have like some private hidden communication. Information security, on the other side, talks about securing data, okay, locally. So even if I'm storing data locally, it has to also be secure, which means no one will have access to it. I have to have access control privileges. I have to have some restrictions on the file. Not anyone can read that file and so on. Okay, so this is information security. It talks about securing local data stored on a server, whereas communication talks about securing data while it's being transmitted. Depending on the types of application, as we said, the level of security that we have is different. So if I have very sensitive application for, like, for example, banking, or for intelligence, or for medical application, that requires very high level of security. But if again a normal person is browsing the internet, okay, not مثلا buying things from Amazon or something like this, because that requires credit card and some critical information to be used. But if you are just browsing the internet, freely like this, then that does not require the same level of security like other critical applications. واضح كده؟ So again, the network has to be smart to provide different levels of security based on the type of application. واضح كده؟ Any other questions يا شباب؟ So we'll stop here inshallah. Next time we'll talk about another topic, the changing network environment. Okay? Any other questions?